Hi everyone, good evening. So today we will talk about VNet peering. Yesterday we discussed about what is virtual network and how to create virtual network and how to create subnets inside that virtual network. Once the subnets has been created, how to launch the VMs inside those subnets, it's been discussed. So now in today's session, we will discuss about the VNet peering. So what is this VNet peering? VNet peering is to establish communication between two different networks, means two different VNets. So yesterday we have seen this way. For example, here, this is one VNet and this is another VNet. So in this VNet, we created subnets, and inside these subnets, VMs also able to create. But this VM cannot able to communicate with the another VM which is created in the different subnet, different VNet. So always this is isolated, and this is VNet is one of the security also. Like whatever the VMs you are creating, it can be 10 subnets, 2 subnets, 100 subnets. Only they will communicate in the that specific VNet itself, but they cannot go and talk to the other VNets. In real world, there will be more than one VNets will be available. It will be not only single VNet, and all the VMs will be created in the same VNet. So you'll be having multiple VNets. Now, if you have multiple VNets, then sometimes if you want to communicate your servers from one VNet to the another VNet, then you need to enable peering between these two VNets, so that machines from here to here and here to here, they can able to communicate. Like if you go to the Azure document, yeah, like VPC in AWS. So Azure VNet peering. So what Azure document says, virtual network peering enables you to seamlessly connect two or more virtual networks. Here virtual networks means VNets. In Azure, the virtual networks appears as one for connectivity purposes. The traffic between virtual machines in peer virtual networks use the Microsoft backbone infrastructure. Like traffic between virtual machines in the same network, traffic is routed through Microsoft's private network only. So Azure supports the following types of peering. So this is important. So virtual network peering means which we call as a local peering and a global peering. So connecting virtual networks within the same Azure region and connecting virtual networks across Azure regions. So there will be multiple scenarios or use cases will be there in the real world. It's like, for example, use case one. If you take use case one, same location and same subscription. Here location means what? Region, which means your VNet is in the same region. If you take, for example, region East US, and subscription is also same, and destination region is also same, East US, means both the VNets are in the same region and under the same subscription. This is one scenario. And another scenario is belongs to same subscription but different locations. Same subscription but region is different. Maybe one VNet is created in East US and another VNet might be in the west to US. And another scenario is like belongs to different subscriptions and different locations. So subscription is also different and location is also different. And fourth scenario can be like belongs to different subscriptions but same locations. This is also it's possible. Like maybe here different subscriptions means again two things will come. In one tenant you'll have multiple subscriptions, or it may be multiple tenants. Multiple tenants means different account. Right now we log in to the Azure with some credential, that is like top level tenant, and you have another account, another maybe some customer side, another network is also available in the another tenant with another credentials. So there you want to connect. So that way is also comes under this scenario only. Okay, it can be different subscriptions or maybe tenant. So this way, these many ways you can establish peering. So we'll try these two. Okay, these are not possible. So these two scenarios we'll try. So here this is called as an global virtual network peering. Why? Because connecting virtual networks across Azure regions. So across Azure regions means this is East US, this is West US. Same tenant, same subscription or different subscription. Okay. So end of the day, same tenant, same subscription. So different regions, East US and West US is called as an global virtual network peering. Local network peering is connecting virtual networks within the same Azure region. Means this one. Same account, same subscription, same region. So, but you have multiple VNets. Like we have a tenant and we have a resource group here, RG, and under this we are creating a VNet. And if you create multiple VNets, so these are like VNets. So these all are created under the same East to US, but still they cannot communicate each other. Like assume this is having one subnet, this is having one subnet, and this is also having one subnet. And in each subnet, assume you have one machine here. This is a VM. So they will not able to communicate by default. So this VM and this VM cannot communicate because they are in the different VNets. Even though it is in the same region, it doesn't mean that they will communicate. So VNet is completely isolated and it will not able to allow VMs to go and talk to the another VNet even in the same region. So this is called a local peering. So global peering means if you have West US, same you create a VNet here, and here also different region you have a VNet, and you have maybe one subnet, and you have one server, and anything you can take example of this one, this one, this one, doesn't matter. Like from this VNet VM to here, if you want to establish communication, same you need peering, but this is called as an global peering. Okay, understood? So this you need to understand. Or else just now we discussed like this is one tenant, and the same way another tenant, different account from here to here, maybe here to here, because this is a different tenant, and this is West US, this is East US, different subscriptions or different tenants and different locations with this scenario. But different tenants, same location means this one. In this tenant East US and in this tenant East US, different subscription mean different tenants, but same region means this one. Different regions means west US to east US. Different tenants and different subscriptions. This we cannot achieve, but the two things, local peering and global peering, we can able to try. Okay, so this one we can able to try here. So we'll create uh, multiple resource groups and this VNets, and then we'll do this practice. And before that, I would like to give an example. First of all, why we need to communicate. What is the purpose of establishing the communication in what scenarios? So I will give one of the example. Once finishing the session, you can ask the questions. Okay, I will clear all the questions once the session is completed. So if you type hub and spoke model in the hub and spoke model Azure, as of now they updated the diagram. This is an architecture, so I don't want to discuss about this architecture because it will be more little bit confusing, but if you understand easily, it will be very easy, very simple. But instead of that, which I used for previous batch, I will show that diagram. That will be more easily to understand instead of these heavy diagrams. Okay, but it's very simple. This is 1 minute, this is 1 minute, 1 minute, 4 minutes it is showing. Okay, and this is your on-premises data center. Instead of that, I will show you another diagram, the old diagram, which previously when they were using for the same reference topology. So this I think bit easy to understand. So this is called a uh, hub and spoke model. In coming classes also we'll discuss about this. So here uh, this spoke virtual network is, virtual network means one VNet. Spoke virtual network is, this is another VNet, and hub virtual network is another VNet. Three VNets are there. Generally, in coming sessions, when we talk about firewall, VPN gateway, again we'll talk about this, right? So as of now, just assume these are the three uh, VNets. So in this VNet, only one subnet is there, resource subnet, and inside that subnet, three VMs are created. And here also one subnet, three VMs are created. So now in real world, whenever you want to go and access to the on-premises environment or to access the internet, it should go via this firewall. So in coming classes, you'll understand in what scenario you use bash and VPN gateway, all these things. Just so in this way, it will go and access the external world. So in this virtual network, in the VNet, these are the three resources has been created. We call it as an virtual appliance. We call this as a virtual machines. We call this as an virtual appliances. Okay. So in coming classes, we create Azure Firewall, VPN Gateway, Azure Bash and Burst. As of now, to understand these VMs to go outside and access the on-premises environment with the help of this firewall. This VM will come here with the help of this. It will go and access the external world, or to access the internet or some other customer, something like that. So these, whatever the hub VNet is there, obviously there should be a communication between this VNet and this VNet. Otherwise, VM cannot able to reach this Azure firewall resource which is available here, because this is different VNet and this is different VNet. So without communication between these two, then VM cannot able to reach Azure firewall, and from here it cannot go and talk to the external on-premises network. So that's the reason between this hub VNet and spoke VNet, you should enable peering. If you enable peering, then only there should be communication will be established between these two VNets, and then only it can reach firewall, and from firewall it can go and access the external world. Same way here, this is also same, another VNet. It should also have virtual network peering, between this one and this one, then only it should go and access the external on-premises environment. So this is one of the real-time scenario why we will enable peering. Compulsory to this VNet, remaining VNets. Apart from these two, if you have more VNets and all these VNets, if it want to access this Azure firewall to go and access on-premises or external world, then definitely there should be a peering should be enabled between hub VNet and the remaining spoke VNets. Understood? So this way, this is one of the reason why we enable peering. So that's why we are learning peering. Understood? So you can get this latest same here also they are telling the same thing, but they mention now production spoke VNet, production spoke VNet, two they provided, and here non-production. One is enough, one production, one non-production, but they mention multiple things here. And same, this is hub virtual network VNet, it is available, and this is on premises. That is the only difference. But by looking at these many lines, diagrams, all of a sudden, initial stage, it may feel like complicated. So that's why I was not preferring this diagram, the latest one. But the concept is same. And now, how to create that? So what we are going to do now? Now, I'm going to. What are the things we need now? We need to create a VNet, and only one subnet is enough. Why? Because we don't want multiple subnets, because this is for testing between one VNet to another VNet. So if one VM is available, that VM will go and talk to the another VM. So same way it is going to be this way. So I will configure in like East US, and local and global we can discuss. And same way here, this is might be West US. So this way we can. So once this is created, then we'll see whether this machine and this machine communicated, and this machine and this machine will be communicated. East to US to West US is a global, and East US to East US different VNets, whether they will communicate or not, we'll see that. So for that, I have prepared a document, and whatever I created yesterday, everything it has been deleted. That is not required. Again, we can create all the new VNets and subnets, but through the command line only. Creating of VNets and subnets and virtual machine will show in the command line, but how to do peering will show in the console to easily understand. So for that, I have a this GitHub documentation same. So I'll go there, and I'll take the VNet document, VNet peering here. You see. So what I'll do, I'll copy from here. Maybe till here is enough. I'll give in a notepad. So if you see here, this is to create the VNet peering, and the first one is, so how it is divided right now. What I'm going to do, for all these things, I'm not going to put all together under one RG. So I want to, we can put it in one RG also. There is no difference, but I'm going to use something like a blue RG with colors each. This is the one, red RG, different resource groups individually, orange or yellow. So if you see here, I'm creating first one, resource group is getting created, red RG, and then network is getting created, VNet, create -G, and this is the resource group name, and this is a red underscore RG -VNet1. So this is a VNet name, and we are using hyphen address hyphen prefix 10.1.0.0 and one subnet is enough. So subnet is also getting created along with the VNet. Red hyphen RG hyphen subnet 1, and the prefix is this is a subnet 1 where it is getting created hyphen L West US, and same way second one RG is getting created, and this time it's an orange RG. Same VNet we are getting created, and the name is orange underscore RG underscore VNet 1, and this is a prefix, and this is a subnet to create, and from this range this is a subnet. I am taking three types of IP addresses like 10 series, 172 series, 192 series. All are private IP range only. So this is a main address space and this is a subnet. So three VNets it is getting created, and three subnets in each VNet it is going to be created. And after that, I'm going to create a VM in each VNet. So red RG underscore VM, orange RG underscore VM, blue RG underscore VM with the Ubuntu image. All the three are Ubuntu, so that I can log in. I can use ping command to test it. And the username is CloudFree, and password is this is a password, and size is this is a one. Understood, right? So instead of this, we'll go with a different one. Mm, it's like this is and now we'll have three, and the color will be uh, what is the color? Where how to change the color? Why it is not showing the color? Okay, here I need to select right. Forward. Now, yeah. So this will be like red, and this will be like sorry orange, and one more is like blue. Okay. Now I'll write down the IPs also here. Red RG IP range is this one. This is a VNet IP. This main box is VNet, and this is a subnet, and here this is a subnet. Done. And next one is orange. Orange is 172 VNet IP range we are going to use, and then subnet range is this one, and for blue RG this is a 192 series. So you can use 10 series also, means 10.1.0.0/16 and 10.2.0.0/16 and 10.3. That is also possible. Okay, I just for a different purpose I choose these three different IP ranges. You can choose 10 series also. So this is a one. Now we are trying communication, like for example here or here this way. So let's see this one. If I enable peering between these two will communicate. If I enable peering between these two will communicate. Okay, so we'll see how it is going to work. So first we'll try with red with the orange. So before that, we should create all these resources. As of now, these are simple VNets, subnet, and virtual machines are going to be created. So what I'm going to do, uh, you can do one thing. If all the commands are correct, you can copy all these things and go to the cloud shell. Okay, here you can use, and yesterday I couldn't able to open that shell.azure.com side by tab also you can use it. So here shell.azure, that way also you can able to open. You in the same tab, if you're opening, it will not ask for the credentials. Automatically it will take from the previous tab, and you can able to get the shell. So this is the dashboard console and this is the shell. So what you can do here, you can create a files vi vnet creation dot sh. This is a file name I can create, and inside this insert, but so all the commands whatever we execute manually, I provided inside this one. In single go, everything will get created if there is no mistakes in these commands. So I will just give a try. So in this scenario, I'm just creating resource groups, vnets and subnets are getting created. So now just save it, and you need to change the permissions, because if you see it doesn't have execute permission. So chmod 777, give the file name so that it will give the permission. Now you have execute permission. Just use dot slash vnet creation execute. So if it works, then it will not give any error. One by one it gets created. So first it's created rg, and then it will create vnet and then subnet. Then it will create orange rg, vnet, subnet. That way one by one it will get created. So very easily you can save a lot of time instead of going to the console dashboard and selecting each and everything. This way also you can able to create it. So right now we are just creating vnets and subnets under each individual resource group. It's done. No error. Just go through, because sometimes some errors you can find in the complete output, but I don't see any errors. Fine. And the same way, we can also complete the VM creation also. So VM creation also, what I'll do, I'll just copy these three commands, nothing but copying these three commands and keeping inside one file. And now this time I will create a new file. This is VNet creation. Then I'll go to use VI VM creation dot sh, and here insert. This is not a script. We are executing it like a script, but putting all the commands inside a file, and we are just executing it as a script. But don't feel like I'm using some scripting here and executing here. These are just instead of executing individually, I'm executing all together in single go. So here three VMs are going to be created now in the three different subnets. Now same dot slash VM creation. Now before that we need to change the permission. Chmod, this is a Linux command to change the permission. And now dot slash VM creation dot sh. In the meantime, we'll go and see whether VNets has been created or not. And if you see red RG, orange RG, blue RG, VNets has been created under three different resource groups. And if you see these two are in the West US, this is in the East US. So this is for local peering purpose and this is for global peering purpose and a free trial. And inside this, if I go to one of the VNet, I can see subnets. One subnet has been created and 251 IPs are available because slash 24 means this is class C. Basically, you should get 254 IPs. What about these three IPs? These three IPs generally, whenever you create a class C IP range, you should get how much? 254 IPs by default. If you remember in the subnet calculator, Google subnet calculator. If you see here, for class C, how many hosts per subnet? 254 hosts means 254 IPs you are going to get for the class C. So for 10 series also, when you are giving slash 24 means it's acting like a class C. So you should get 254 IPs. But why you are getting 251 here? What about those three IPs? So 10, if you take 10.1.0.0 slash 24 means this 10.1.0.0 to 10.1.0.255 up to here it will be there. This 0 is a network ID and this is called as a broadcast IP. So this we don't assign to any machines. This is a broadcast IP. So obviously it will start from 10.1.0.1. It will start from 1 and it will 10.1.0.254. So this 1 to 254 means 254 IPs you should get. But here we are getting only 251. 3 are reserved. So for what purpose it is reserved? These 3 IPs are reserved because 10.1.0.1 is a gateway IP. We call it as a gateway IP. That is the reason it is reserved. And 10.1.0.2, 10.1.0.3 is reserved for DNS. So whenever you start creating a machine, it will start with 10.0.4 onwards. So you are wasting 3 IPs for every subnet here. If you see here, DNS servers, when we talk about DNS at the time, we'll understand. So for that, it is reserving 2 IPs. And by default, the first IP will be always it used for the as a gateway IP. So 3 IPs, if you have 10 subnets you created in single VNet, then 30 IPs it is going to be reserved. But in real time, it's very worthy. The 30 IPs also we cannot take it light because every IP is very important. So that is the reason whenever you're designing, you should design in a such a way that should not waste more IPs. In that way, you need to create your VNet, subnets, everything, routings, all should be in the correct way. So here for each subnet, by default, 3 subnets are reserved. So now I think machines also got created. What is meant by 24? 24 is a bits. Yesterday I told you, like yesterday I think you missed the class. Yesterday I discussed about this bits concept. The same way whatever we give 255.255.255.0, so that we will give at the time of your configuring the IP to your machine. But generally other way also you can use slash 24 means whatever that bits, 8 plus 8 plus 8 is 24 bits. So that is a nothing but a subnet mask. 24 is understood, Pawan? I think yesterday you did not join. Now in each VNet we have one subnet now. Okay, why it is showing 250? Because I think VM got created, I think so. So here also 250, and first one also should show 250. Yes. So just we go and check the VMs now. All the VMs also got created: blue RGVM, orange RGVM, red RGVM. So now I'm going to connect to these machines. And first of all, we need to test it whether they can able to reach one machine from the another machine. So I'll go, which one is the first one? Red RG. Okay, I'll go to the red RG VM. Obviously from outside we are connecting, we should take the public IP and use this tool, session SSH, and username. I provided Cloud Freak as a username, but I don't remember what is the exact password. This is a password provided. So, okay. Now it is asking the password. Enter. Secure master, retype master pass. Please enter master in order to put your password. What is this? Okay, mission got I logged into this red RG VM. Now you zoom in. Now what we need to do from here, I'm going to do the ping test to which machine? To the orange machine. So from this IP range, some IP got assigned to that machine. Let me go and check. So orange VM, and if you scroll down here, you can see the private IP address of the. Always remember, don't test with the public IP. Internally, they are trying to communicate. Externally, from my laptop to reach there, I am using public IP, because internally in within the cloud, we created multiple VNets, and internally they should always try with the private IP only, not the public IP. So I am taking the private IP of Orange VM, and if possible, we can place it here also. And this is the IP of the VM. So now sitting from here, I'll just do ping. I cannot able to ping from here. From here to here, I cannot able to ping, and vice versa also we can check. Log into this machine and try to do ping to this machine. That is also possible. I'll do that. So now I'll go to the orange machine public IP, because I need to connect to it. So from external world, if you want to connect, you should have the public IP and use the IP. Same Cloud Freak is a username. Okay. In the first time, accept, and the password is zoom at the rate. Now connected to the orange machine, and here I'll try to do ping the machine IP of the red VM. So I'll go to the red VM. I'll take the private IP here. So this is a private IP. Take this IP and ping. no communication. So this is a general expected scenario. So two VMs from two different VNets cannot able to communicate, and this is an IP of this VM. Now we need to enable peering between these two. So it's very simple. You just go to the VNets now. Home, virtual networks, go to the red RG VNet because I'm going here. So establishing communication from here. If you go down, you can see peerings. So select peering and add and provide the name. So what is the name? Red to orange peer. This is the name I want to give. And traffic to remote virtual network. So remote virtual network, you want to allow or block it. Obviously, already by default it's blocked. So we should allow. So traffic to remote virtual network means whichever virtual network which you are going to select now. And traffic forwarded from remote virtual network. So this meaning you need to understand. Traffic forwarded from the remote virtual network means there is a difference. Traffic from remote virtual network and traffic forward from remote virtual network, there is a different meaning. So traffic from remote virtual network means what? So here to here. So whatever the traffic want to come from here to here, you are going to allow. But traffic forwarded from the remote virtual network means, suppose there is some other VNet and this VNet is also having the same like peering between these two. We don't know that. This VNet doesn't know about it. How many other VNets is also having peering with this VNet? But if that is the case, allow traffic from those VNets also. That is the meaning. So not only this one, allow traffic from the other VNets which are peering with this VNet. So that is the meaning of this one. Okay, if you see here, this setting allows forwarded traffic from remote virtual network. Means traffic not originating from inside remote virtual network, which means not the remote virtual network. So whichever networks are connected to that remote virtual network also you can forward to this one. That is the meaning. So that is also you can mention allow. And this week we'll talk about later when we talk about VNG virtual network gateway. At that time we'll talk. As of now, it's none only. And now it is asking remote virtual network. See, here it is asking this virtual network. In the same page, it is asking about the remote virtual network. So now here I am going to give orange to red peer, vice versa. Why? Because uh, here to here we are giving. So here to here also this way and this way is also required, right? If you want this way also you need to provide. So here to here you want communication. Same way here to here also you want communication. Then it is asking peering link name and virtual resource. Classic is an older type of methodology and the resource manager is the latest now, whatever it is providing now. And here virtual network, you need to select the orange one. Understood? So right now it is going to create two peering connections. One is from red to orange and second it is asking orange to red also. If you see here, we selected orange red and it is also asking same questions. Traffic to remote virtual network. Now remote virtual network, red is a remote virtual network for the orange. And same way traffic forwarded from remote virtual network. This is also the same one. So this way in a single screen, you are going to create both. Understood? Now in the same screen itself, I want to explain uh, the use cases which we discussed, right? What about these two use cases? Not where is that? This one. we can practice these two use cases because both are in the same tenant, right? Same tenant, that's why we can able to select this one. But if it's a different tenant, then how we need to configure it here? Then you need to choose, for example, different subscription you can choose here, subscription tab, and different subscription you can choose. But what about different tenant? If it is, then you should mention here, I know my resource ID, and select this option. And if you go to the different tenant, wherever that tenant, someone else like client, means different customer, you want to reach to their VNet, then you should have the resource of their VNet. You should ask them, whoever raised the request to establish communication between your tenant VNet to some other XYZ customers VNet, then you should ask the um, resource ID. So now, how to get the resource ID? If you go to that virtual networks, you can able to get the resource ID. If you go and select the VNet, I will go and select any of the VNet. Mm, somewhere we can find the resource ID. So with the help of that resource ID, we can able to provide it here, like how you mentioned subscriptions, the subscription name, under which resource group it is provided, providers, all this information. So when you select this and when you click on add, then it will prompt you for the authentication, because here you are in the same tenant, it doesn't expect any access now, but you are trying to access someone else network in the different tenant. So directly it should not go and access, right? So it will ask for some authentication. So what you need to do, for you need to have a credentials in their account over there. So you should use those credentials here, then it will go and connect to that particular VNet. So when we talk about Active Directory, at that time we'll discuss about that. Generally, there will be a contributor user will be there, network contributor user will be there. So based on that, you will get a limited access. Those credentials you will use whenever it will prompt you for the authentication. Then once you provided that, it will go and connect to it, and it will create peering between your VNet and the other VNet. Like in the initial classes, someone were asking how to manage these multiple tenants, VNets, all these things. So this is how you can enable VNet peering between your tenant and the another tenant. So, but as of now, we are not doing that. So I'll just remove this. I know my resource ID. I'll just select this free trial. Okay. So now this is how we are going to create, and so two peerings are going to be created now. Add. If you see, add virtual network peering, orange to red, red to orange, it is going to be created. And it is very quick this time. Immediately it is showing connected. So if I go here, it should show ping then. Maybe the other side is not created. Both are showing connected. Yeah, now it's coming. If you see, ping is coming. And this machine also started pinging. It took some time to establish connection. Now both are able to communicate each other. From red to orange and orange to red also, we can able to communicate. Understood? So this is how we'll establish peering between two different VNets. And now we'll see, we already completed this one, and we can do this one also, like orange to blue also we can do, or orange to red also we can do. But as of now, this is independent, so no one able to connect to this machine now. So now let's try orange to blue we will try same way. So what I'll do, I'll go to the blue RGVNet and then peerings, add peering, peering name. Uh, this is just a second. Let me check virtual networks. Yeah, blue is East US and orange is the West US. Then it's fine because we are trying global peering. So peerings, add peering link name blue to orange peer and same allow and allow and ignore virtual network gateway and same way here we are giving orange to blue peer and same select resource manager and no need to select my resource ID and free trial here virtual network orange. So I'm selecting because from blue to orange we want, and for orange also I'm allowing allow traffic to virtual network and forward the network, and remaining virtual network gateway you can ignore and add it. So now again two virtual network peerings has been established. So previously it used to take some time updating, but now it's immediately connecting. But now we should go back to the virtual machines and I should log into the blue RGVM because till now I did not connect it to this VM. Take the public IP and open a new session, and the username is Cloud Freak. Okay. And then log into it. So once we log in, we just try to connect to the orange VM. So what is the IP, private IP of the orange VM? Select the orange VM, scroll down, and here we can see this is a IP address. Take it and ping. See, we can able to connect from blue RG to orange also, and we'll try vice versa from orange to, and what is a 172.16. So this is orange RGBM, and from here we'll try blue, and what is the IP of blue? This is the one, and you can ping. So successfully we can able to communicate. So this is how we'll establish peering. As I said, with the spoke and hub model, it compulsory requires in the real time about this peering, how we establish peering, all these things. Understood? So this is about the peering, and tomorrow I will come up with a new topic. If you have any questions, you can ask me. Local and global both are same way. Yeah, same way. Only thing is that is in different region. This is in different region, but concept is same, and they both can able to communicate. But the naming is like two different regions. See, mostly when you work, it will be only single region only. Whenever your business is in specific country, it will be single region. Sometimes you will use different regions also, but lot of operations are running on different regions. There will not communicate that much easily or regularly. Then if it is required, then you need to enable this peering so that they both can communicate. So that is global. But regularly you will need peering between your local only. In one region, in real world, you select one region, and most of the businesses will be in that specific region only. So that's why they name it as a local and a global. Same network means, I did not understand this. VNet of same net. See, when you are creating a VNet, obviously it will be a different network. Like if you are choosing a 10.1.0.0/16 means what? It's one network. With the same network, you cannot create another VNet, right? When you are creating VNet, it will ask you the address space. So when you provide the network range there, the same network range again you cannot provide to different VNet. You should give different address range. So when you give a different address space, then obviously they both will not communicate. Then you need peering. Two different VNets will never communicate by default. To disable, yeah, we can do that in real time. Will in private subnet, yeah, servers will be in the private subnet only. VMs won't have public IP. Yeah, we'll discuss that in coming sessions. Obviously, that is mandatory that we should not have public IP. Only for specific machines only we should have the public IP, and that too manually we will create the IP and we will assign attach it. But automatically public IP should not be assigned when VMs are getting created. That definitely in coming sessions you will know that. Srinivas, you can check with the management team and you can go with the recordings if you missed the previous sessions. Can you please test ping from red to blue? Yeah, we can do that. Right now I am in orange. This is red. This is red. I think this is blue IP. Did you see? Because there is no VNet peering between red and blue. So that's why it is not accepting. And vice versa also you can check. This is red and this is blue. No communication. If public IP VM will restart, the VM will assign new IP. If not, elastic. Generally, it depends for how long your machine is down. If it is down for longer period, then obviously it will get the new IP. Or else you need to attach the static public IP. You need to create static public IP and you need to attach it. Mobile extern, yeah, this tool you can use not only for doing SSH to the Linux servers, you can do FTP, VNC also with this mobile extern. That's why I prefer single tool for everything instead of using PuTTY. Yeah, Rajesh Chopra in Hub and Spoke, there is a concept of its listing. In coming sessions, we'll discuss more about this hub and spoke concept. So there you will understand more details like NSGs, firewalls, whatever you're talking about, whitelisting, everything. In real time, what we use bash or PowerShell commands. We don't use bash or PowerShell. We use ARM templates and Terraform to create infrastructure. Saya kill. Krishna Chaitanya. If there is a same shader, if they acquire different company, they will try to change the shader of the acquired company, whatever it will be in the, to make it into the different network. Private IP conflicts, you won't get any private IP conflicts because VNet is assigning IPs to your virtual machines and appliances. So you are not manually assigning it, right, to get conflict. Based on the available IPs only, it is going to provide the IP. Peering both ways, or it is automatic, or manually we need to set. Peering both ways, whatever we did now, the same way. Both ways only you need to do. Only single way it is not possible. Automatic way means manually only we need to do. Either you need to through the console or through the command line or through the Terraform. You need to do that. Yeah, automatically from B to A, automatically it will create because both the options it is asking the same page. So when you click on add, automatically the second one will also get created. We did not start NSG concept. In coming sessions, we are going to talk about NSGs. Yeah, in our template, you need to provide authentication credentials. Then only it will go and connect to your cloud. Whatever the subscriptions you have to get access to that, you need to provide access. Those credentials should be defined inside the templates. Same process in AWS for what? For peering. Peering little bit same in AWS also. Yeah, same, almost same. Network count, I never searched it. Even I think Azure also did not mention in their page how many uh, peerings it will be allowed, any number of peerings. We should not focus on those number of uh, numbers because it will keep on change. Whenever they are increasing the infrastructure, they will improve the options, right? So today it may be one value, tomorrow it may be with a different number. So they never mentioned about the peanut peering values, the limits. Maybe we can search that. Limits up to 500 virtual network peerings per virtual network. One virtual network, like 500 virtual network peerings you can establish, it seems. Okay, guys, thank you. Have a nice evening. Tomorrow we'll meet at the same time with a new topic. Thanks, everyone.